By the end of this century, a dream as old as humanity's reach for the stars may finally come true. The legendary space elevator. Imagine stepping into an elevator on Earth, pressing the button marked up, and beginning a smooth ascent, not just a few floors, but tens of thousands of miles, into space itself. Like the mythical beanstalk from the fairy tale of Jack, this elevator would carry us beyond the clouds, past the edge of our atmosphere, and into the boundless cosmos. The story begins more than a century ago, in 1895. A visionary Russian physicist named Konstantin Tsiolkovsky found inspiration in a surprising place, the Eiffel Tower in Paris, then the tallest structure in the world. He asked a simple yet profound question: why can't we build an Eiffel Tower that reaches all the way into outer space? Tsiolkovsky imagined a celestial castle, a tower so tall it would never fall, held in place not by beams or bolts, but by the very laws of physics. To understand how this might work, imagine a ball on the end of a string. Whip the ball around fast enough, and the centrifugal force keeps it spinning, suspended in the air, defying gravity's pull. Similarly, if a cable were anchored to Earth and extended far enough beyond geostationary orbit, about 22,000 miles above the surface, the spin of our planet would create enough outward force to keep it taut, stretched into the heavens. Along this cable, an elevator car could ride, traveling up and down, turning the dream of affordable space travel upside down. But the dream came crashing down when physicists applied Newton's laws to the problem. The forces pulling on the cable would be tremendous, far beyond what even the strongest steel could withstand. The cable would snap under its own weight, making the space elevator impossible with the materials known at the time. For decades, the idea was revived again and again, only to be rejected. Then, in 1957, a Russian engineer named Yuri Artsutinov proposed a radical new approach: build the space elevator from top down, rather than bottom up. Instead of constructing a tower from Earth, a spacecraft would first place an anchor satellite into orbit, and then a cable would be lowered down to the planet. This reversed engineering offered new possibilities. Around this time, science fiction writers like Arthur C. Clarke and Robert Heinlein brought the space elevator into popular culture, imagining how humanity might one day climb skyward on giant cables to reach the stars. The breakthrough that might finally turn the space elevator into reality lies in the realm of nanotechnology, specifically carbon nanotubes. These remarkable structures, made from sheets of carbon atoms rolled into tiny tubes, are stronger than steel by orders of magnitude. Their tensile strength, their resistance to breaking, is precisely what we need for the space elevator cable. The problem? Creating a carbon nanotube fiber thousands of miles long, pure, flawless, and able to bear the crushing tension of Earth's gravity and centrifugal force. So far, scientists have only created tiny fragments, mere centimeters long. Weaving billions of these into cables produces strong materials, but not pure enough to withstand the extreme demands of a space elevator. In 2009, a team of scientists at Rice University announced a promising breakthrough. They discovered a technique that dissolved nanotubes in a special acid solution, then extruded them like threads through a nozzle, producing fibers hundreds of meters long. Though these fibers aren't pure nanotubes, they offer tantalizing proof of concept, a glimpse of a future when continuous nanotube strands may be manufactured. If the cable can be made, the next challenge is the environment it must survive. The space elevator would stretch far beyond geostationary orbit, into regions crowded with satellites traveling at 18,000 miles per hour. Collisions with satellites are inevitable unless the cable can move or dodge out of the way. Engineers envision rockets or thrusters attached along the cable, shifting it temporarily to avoid catastrophic impacts. Weather on Earth presents another formidable obstacle. The anchor point for the elevator might be a floating platform, an aircraft carrier or oil rig, in the Pacific Ocean, far from population centers and shipping lanes. But hurricanes, lightning storms, and high winds could threaten the integrity of the cable and elevator system. The design must allow flexibility, bending with the forces of nature rather than resisting them. And what if the cable breaks? Safety is paramount. Escape pods equipped with parachutes or gliding mechanisms would ferry passengers safely back to Earth in emergencies. Panic buttons, redundancies, and rapid response protocols would be integral parts of the space elevator's design. To accelerate research, NASA has launched the Space Elevator Games, a series of contests with prizes totaling $2 million. One challenge requires teams to build a device weighing less than 50 kilograms that can climb a tether at 2 meters per second without carrying fuel or batteries. Instead, energy must be beamed wirelessly to power the climber. In Seattle, one of the most promising teams working on the space elevator concept is Laser Motive. Inside a large warehouse, a powerful laser is directed at a small elevator box traveling along a cable. The laser beam strikes a mirror on the box, reflecting onto a series of solar cells that convert the light into electricity. This electricity powers a motor, gradually pulling the climber upward along the tether. The intensity of the laser beam requires everyone present to wear special protective goggles. Through repeated trials, the climber steadily ascends the cable, a crucial and tangible step forward in the quest to build a functioning space elevator. In 2009, at Edwards Air Force Base in California's Mojave Desert, the Laser Motive team won the Beam Power Challenge. Suspended beneath a helicopter, their device climbed a long cable 4 times over 2 days, the fastest run taking just under 4 minutes. The space elevator remains a dream on the horizon, a bold vision that blends imagination, science, and relentless human ambition. If the challenge of creating a strong, pure nanotube cable is overcome, and the engineering puzzle solved, the space elevator could revolutionize how we access space. It promises to open a new chapter for humanity, one where the sky is no longer the limit, but just the beginning.